So it's been a delight seeing both of the gentlemen here. They are like amazing human beings. They have done pioneering research, not in just one area, whether it's data, AI, and they have started a company which every academician dreams of, which is powering essentially the AI era, called DataBricks. So let's start with your journeys, and there's a lot of people here who are students, they're entrepreneurs, people who want to be entrepreneurs, and people who are practitioners. So let's start with you, Jan. How did you get to what you're doing today, and what drives you? And then I'll get to Matej.
I think that, what drives me, and I think like this is true for many people, it's a desire to have some positive impact, right, about whatever you are doing, to be used by people, and in that process to make the life of those people a little bit better. And of course, it can be engineers, or in our case, or data scientists and things like that. But that kind of drives me, and again, I think that many other people. It creates something which is useful for other people.
Great. What about you, Matej? Right? Like, what's been the driving force behind your research, entrepreneurship, and what you do today?
Yeah, the nice thing is this is true both for academic work and for industry work.
And your viewpoint, Matej?
Mm-hmm. Yeah, I mean, I think basically, making people's lives easier through technology was always a thing. And then also, when I began my PhD, which was with Jan, by the way, I just saw there's this big disparity between what the cutting edge sort of tech companies were doing and what everyone else could do, and what could be possible with that technology. So it was all about how can we take the stuff that's possible technically and enable more people to use it.
Got it. How many people from Stanford here? How many people from Cal? Great. So I think I'll be careful because we have a Cal grad, comes to Stanford and goes back to Cal, so you guys will. Should feel good. So tell me, right, I was a student myself in the mid-90s, worked for Professor Anup Gupta and John Hennessy, and we started vExtreme. In 90s, it wasn't common to spin out of university and do a startup, and we enabled video streaming over the internet. How has your lab focused on creating so many projects which go beyond papers to solving real problems and then ending up creating companies like DataBricks, right? Do you guys have some special water? How does that thing flow, that culture?
Yeah, I think that with many of these projects, and including with Apache Spark, which was created by Matej, that we have some of these projects, and we are maybe early on in that particular space, before Spark was Mesos and so forth, and they started to get some traction. And now you get to a point in which some companies, some enterprises are going to think about making a longer-term bet of using that technology, that system. And at that point, they are asking the question, hey, what is going to happen when Matej graduates, right? Or the people who are involved in that project. And then you are at a crossroad, right? It's because these companies want to bet on a technology. They want to make sure that there is kind of an entity which is well-financed, which is going to support that project, is going to further evolve it, fix the bugs, making more production ready and all of these things. And so that's kind of, and it's about, again, if you want to go one step beyond that and, again, have a broader impact, then, for this kind of systems, the answer is that someone has to support it, right, longer term and commit to it. And this is what I'm always saying, this story, which is absolutely true. Matej, you remember, we actually, initially, we wanted to donate Spark to another company, which was one of the Hadoop companies. Again,
and they were probably here on an earlier panel today.
But because we work with them and we know each other very well, And I remember exactly, you are in the room, you are basically saying, look, you want how about you can take over, right? And at that time, they didn't, because also they have internal projects which are somehow competitive, right?
Got it.
So then we decided we are at a good point, Mate graduating, and I could take a leave, and Ali was also ready to take a leave. We have also, it was a very good timing with Andy and Patrick, and already deciding to go and wanted to do a company, and then Reynolds. So it was a good timing, and then, we decided to do a company around Spark and, see how, to, again, push it a little bit more and making Spark more popular and more helpful.
And it's only worth 100 billion today, right? And growing.
Yeah.
What about you, right? Like, why become an entrepreneur? What drove you to do that?
Yeah, I mean, I think it was just a chance to get this to more users and to learn about the use cases. And even early on, like the early users of Spark were doing very unexpected things. Like some people did stream processing with it. Before we had streaming, they just kind of hacked it on top. Some people were doing these like medical or biomedical, research things with image processing that, again, we hadn't really like designed it for. So it was the chance to see that and sort of learn like what's the next wave of challenges people have working with machine learning and with data.
Yeah. Got it. And Jan, like you were the initial CEO for the first couple of years, right? Like any rules of the road on when you're a founder, CEO, what do you look for? How do you create these companies coming from academia? Is it people? Is it the tech? Is it the market you're going after? A combination? Because it's not easy, right? Like when you do research, a lot of it, in my understanding, is consensus, getting everybody on the same page, peer review. But in a company, you're at war. You have to essentially make decisions.
That's a good question. So I think, at the high level, in some sense, you have to really be able to take advantage of the luck you are going to have. Because it was a lot of, like people say, we are at the right time, and we are doing the right thing. So it's a lot of pull from the industries. Again, that's why we created the company in the first place. And I think what you are saying is about what is most important, of course, and we are a very, I think we are a great team. We've been working together for years, almost everyone in the founding team. So we knew each other. We already spending nights with these projects at Berkeley. So you're kind of in that kind of mode. So that kind of transition from that perspective was easy. And a lot of trust between us. So the team was fantastic. And of course, extremely, people, very strong, talented, and so forth. And it's amazing to see even at this stage how much founders are still involved in the company. And not even, mentioning Ali, who became an amazing CEO. And so that's one. But then it's about the market and the problem you are solving. At the end of the day, like Matej said, you are going to try to solve some problems. Your company can never be bigger than the problem you are solving. And, we are the big data at that point, and even today, it's one of the biggest problems out there. And we had, the Spark was the right technology early on. And of course, there are a lot of requirements, like Matej said, from people to use it for streaming, for SQL, and so forth. So I think that, we were able to build a strong team to satisfy and, on the engineering side, these requirements. And I think on the business side, we are also maybe lucky, to make some decisions which are proven in retrospect to be the right decisions.
Got it. And big data, right, and even AI was a thing of the past, and now is thing of today and the future. Where do you think we are in this AI cycle? Are we overhyped? Is it still early, right? Like both from an academia perspective and being a founder, where are we in this cycle?
Well, first of all, I'd say big data is still there today. It's just called data. So
it's the core. It's like the oil.
Gone away. Yeah, it's just there. In terms of the AI cycle, I mean, it's definitely a mix of like some areas are overhyped, some areas are probably underhyped. It's actually, I think it's taking people a while to kind of wrap their minds around like what can you do well with AI and what can't you do, but they're getting a sense of it. And there are a lot of applications that are, landing every day in production that are working well. I would say the coding agents are the most obvious recent one where they're actually useful for a lot of things, but many other things as well with documents and with just in the enterprise space, there are a lot of workflows that people are doing. And in consumer space, there's obviously a huge amount.
And what are some examples in the consumer space you guys have seen, both in academia and at DataBricks and in general with the AI thing? What kinds of things are people doing beyond ChatGPT and
I mean, ChatGPT does a lot, yeah. But I would say all the media generation ones too, the sort of personal assistant type things, look at my email, summarize what's going on. But ChatGPT does a lot. I mean, ChatGPT with deep research and with tools and stuff is doing a lot more than it used to in the past.
Got it.
Yeah.
So question for you, right? Like you've been doing research for many, many years. You think we are done with the foundational models, right? Like I have my own view, or we are just at the cusp of it, right? Because we have a company which is worth 500 trillion, 500 billion, another one 170 billion, and DataBricks at 100. But these AI models, where are we in that cycle?
That's a hard question, right? Because things are evolving so fast, and it's again, when you ask these questions, you have to remember that ChatGPT was released less than 3 years ago, right? It was November, I think 30th November or something like that, 2022. So it's less than 3 years, so it's amazing where we are today, that everyone is talking about these models. Before, only the researchers were talking about these models. So that was kind of adoption and so forth, at least, was phenomenal. So now I think, again, going forward, no, we are not done, obviously. I think that in terms of the models, as you know, these models are, very knowledgeable, but also imprecise and, hallucinate and things like that.
Yep.
Though we cannot say that it's a lot of progress on that side. I think that what you see a lot of progress, it's for domains and for application for which is natural kind of verification of their output, like code assistance, or you can talk about math or whatever. So I think that's kind of, and you have to hope that still a lot of work to improve these models to be not only kind of powerful in terms of the kind of answers they are going to give and solutions they are going to find, but also in terms of the accuracy, the trustfulness, and reliability of the models. So I think that's still a lot of work to be done in that area, and probably also foundational work. And obviously, a lot of work is going to be done at the infrastructure level to have much, cheaper, much more efficient models.
Yep.
We are seeing that happening as we speak.
And what are you seeing, Mate, as far as edge AI or physical AGI is concerned? Because a lot of the stuff that has been done is for data which is open, is available on the web, right? So what about the edge? Because some of this stuff might work, may not work, and then we're entering a world of humanoids, maybe not, but physical robotics. So what are you seeing there in terms of cutting edge work?
Yeah. So I think, so first of all, I think for the LLMs and VLMs, it's sort of clear that in terms of capabilities, they're kind of slowing down a little bit. But for the other thing that's very clear is for the same level of capabilities, you can make the cost go down dramatically. So all these things that like now can only run in a data center could run on the edge or could become less expensive because it's a combination of hardware people working on it, software people, and also just training dollars spent. If you just train a small model for longer, it'll get better. So for sure, like, the GPT-5s and stuff of the world, like soon there'll be something like that you can run on the edge, and that's really interesting. And then I think also post-training them for specific like custom applications is getting easier over time. It's not gonna get harder. We'll just come up with better techniques and algorithms to make them easier, and the compute cost is going to get easier. So in wherever that's valuable, like that's going to happen more and more if it's actually valuable. And then I think the robotics ones are super early. I don't think there are like super widely successful, like generalizable foundation models there yet, although there are some really cool ones, at startups. But I think that, it's going to happen later. Maybe it requires a platform, like a physical platform that's widely accessible also, so more people develop on it.
Got it. What about the cost, Ian, right? Like cost of training, we know where it is, cost of inference. For this thing to be mainstream, are you aware of the kind of work that is happening here? How do we get the cost of AI inferencing down?
I think clearly there is a lot of effort in those directions, and you can see how it's going down. And there are a few things there, right? It's like, first of all, I think you mentioned it, like, obviously model distillations as a technique has proven very successful, right? So training smaller models based on the large models, actually all these foundational model companies, they have one huge models, but they have a lot of much more efficient models, and they are always trained based on the big model. The other thing is that I was talking that earlier today with someone who is doing work on kind of the inference. The inference obviously is one direction it's about. So one is kind of smaller models. The other one is less dense models, like a mixture of experts. For inference, you are going to have only a few percent of the kind of activations, right?
Got it.
All kind of the neurons will be activated. The other one, it's about, especially for large context, with the attentions, right? The attention, by default, is an square operation, so it's very expensive because you need for the next token, in theory, to look at all the previous tokens. So if the context is very large, say 1 million tokens, you have to attend 1 million tokens, right? But now there are many techniques being proposed about reducing the number dramatically by order of magnitude, the number of tokens you have to look at, right? It's like K, sliding windows, and many others. So I think you have, like Matej said, it's both from the hardware and software you are going to see that. And by the way, it's like for the other one is quantization, right? Right now we are going to see 8 bits, and we are going to see 4 bits and less. And you have also the support from hardware. B200 from NVIDIA was supposed to be okay. In general, it's performed kind of a 2x improvement in the performance, maybe 3x. But when it comes to actually inference, what they are saying, if you build DALI, will tell you it's 30x, right? For like when it's highly quantizable model. So a lot of things happening there.
Yeah. And Matej, in your lab, right, like you guys are part of like multiple labs. What is the most exciting research, 1 or 2 research topics that are going on, right? Like it'll be good so that the audience knows what's coming.
Yeah, I mean, I think there are a lot of exciting things. I guess one thing I'll mention is, some of my students and our collaborators have been working on optimizing basically in prompt space. So like using natural language feedback, not just a reward, like a 0-1 reward, but actual feedback and then learning prompt, and which is much faster than learning weights. So it's an example of like, one of basically like customizing your model getting much cheaper, and actually it can learn in a lot fewer steps. Because I think a lot of domains where AI isn't doing so well today are bottlenecked by the cost of doing experiments in that domain and getting feedback. So any scientific domain or anything like that. So this is an example where like just from a few experiments, you can actually learn and make your model better. So this could be another direction where we move beyond gradients and weights to actually like learning rules and kind of coming back full circle to the early days of AI.
Got it. Given that, Jan, like you have mentored many students, helped them start companies, do you guys also teach? So what's your advice? I see some younger students here, right? Like, what should they be doing in this era? What's the best way to learn? What's the best way to participate? What advice are you giving to your students, whether grad students, undergrad, your PhD students, postdoc? Like, what advice are you giving to folks?
I think pick a problem you are really passionate about solving it and solve it. That's kind of the advice I'm giving at all. You have to, and you have to solve a problem you are passionate about.
Got it.
Right?
And any tools like you guys are bringing at Cal for people to start? Because a lot of times people say, don't use ChatGPT, don't do this, don't do that. But how is teaching changing?
I think that, again, if you are focusing on solving as a problem, you don't want to constrain the solution artificially. Right? I think that people will use whatever is convenient, whether you tell them or not. So I don't think you should provide artificial constraints. You might think hard to provide good incentives for what you believe there can be proper behavior. But I don't think it's going to work otherwise.
Got it. And then from your perspective, right, like being a technologist, CTO, what are the biggest learnings you want to share with some of the technologists in the room that you have had, right? Like at DataBricks and before, any 2 or 3 things that come to mind that now that you know this experience, you wouldn't do it again?
Yeah, it's a pretty broad question. I mean, for sure, having a great team is one. Like we're always, we're trying to build the best team and like really empower them to do great things. I think as a maybe more specific, like maybe technical thing, since especially in the AI space, I would say like really thinking about how you evaluate stuff and setting that up so you can like actually improve on something is very important too. And I think a lot of progress actually in AI, in especially like enterprise applications, is limited by how well people can evaluate things. And it's a new kind of thing because the apps are very different from before. It's not like, is it passing all the unit tests or not? You're asking it to do a lot more, to chat with people. Yeah.
And your favorite tool, like what do you use on a daily basis on AI, right? Like any agent, any tools? All of us probably use ChatGPT.
I am using whatever I can in order to make my life easier for whatever I am doing. The point is that not always they don't always work, right? It's like, that's kind of the things. I can tell you kind of one thing I have to do it. And I'm using actually right now, because side by side, Gemini and ChatGPT and so forth. So, like every now and then, at the university, as a faculty and so forth, you need to update your CV, which also needs to update your papers. And it's a particular format. So now I saw that, okay, what I'm going to do, I'm going to tell whatever ChatGPT, hey, go to Google Scholar and look at my papers between this date and this date, and then put them in this format. I give them examples about format and everything. So come back with very few, just a fraction of the papers which are on Google Scholar. I asked both of them the same thing. I did kind of even different papers. Okay, so I say, okay, I try a little bit more, like no success. So I said, okay, like the next things I'm going to try, I'm going to give you the title, right, of the papers. Okay, and just put them in, go look for the authors and so forth, where they were published, just put in the right format. I give that to them, and finally I get a list which kind of looks good. I put in the CV, but when I look closely, it's like it's like, okay, I see that the authors, like the paper I was looking at, they're not right? It's like, okay, I didn't even remember, I remember to collaborate with these people, but not on that project. So go look at the paper. Of course, the authors are different. And it was almost every paper was hallucinating. They were hallucinating, both of them. I'm talking, both of these kind of top models. So now you can say, well, why is that and so forth. Maybe it's kind of out of distribution. It's like you expect this kind of to be an easy question, but not many people ask this kind of questions, right? There are a few of us who are doing it. So yeah, but I'm trying to, do it, use it, but in many cases it's a great tool.
Got it. And using AI, right? Like, do you think you will get cloned, where you'll have your teaching assistant, because with stipends going away, where does this go, right? How do you replicate yourself with the knowledge you have to scale for students? Do you think there'll be a digital twin for each one of you, or that's still
Yeah, so
far
actually,
out?
one thing I want to say here is one class we are teaching right now is graduate class. It's a kind of this disrupting system research with AI. And the main idea is that you can use kind of AI, at least for some narrow set of problems, like an assistant, right, to help you solve the problems.
That's great. What tools are you using personally, right, above and beyond the chat ones that people could be picking? Or any book or podcast where you're learning besides you giving talks?
I think mostly learning from reading papers and things like that, and from doing things, but from trying things. I think it's easier than ever to prototype and try new things.
And for students.
Yeah, and well, yeah, that also makes it easy. Yeah, but I would say the coding agent. So like the Cursor, Cloud Code, DataBricks agent, which is what I'm working on. They really do speed things up, and there's so much more that they could do. So those have really changed things. It's much easier to dive into some new area, even if I don't know anything about the code or the data, and figure something out.
Got it.
Yeah, and this is kind of getting at your other question. I think for sure these tools can accelerate sort of a search and information finding process. And the technology has always been accelerating that, even with the web and stuff. But it's getting easier. So anything you do, teaching, whatever it is, it can help with that.
Got it. One final question before Mr. John shows up, right? He's hiding somewhere. He's being kind. How do you think computer science has been one of the most coveted degrees? Now with coding agents being available, are you seeing students who don't have CS degrees be able to do things they won't be able to do before?
I do see. I mean, I don't know about students, but in industry for sure. Designers at DataBricks are prototyping apps, and product managers are coding and stuff. So for sure, there's stuff happening. It depends on the type of thing, but quickly creating a small app or a small change is quite doable. And the same way, I'm generating images for my PowerPoints or whatever. It's
amazing.
So, that's nice.
Yeah, so everyone needs to learn the new skills, right? I mean,
absolutely.
That's why we are saying is that now you have a lot of kind of equivalent assistants, right? But you have assistants, you have a lot of them, they can do a lot of work, but still can, so to speak, hallucinate, right?
Great.
So you still need to be, so to speak, at least for the time being, in charge.